Hi there, this is Emmy and Courtney, and this is our final project for our digital simulation class at Liberty University, and we are going to be using Monte-Carlo to simulate a hawk-dove game. Basically, we're looking at decision-making with assumptions and the associated risks with those assumptions. So, game theory is basically the process of modeling the strategic interaction between two or more players in a situation containing rules and an outcome. We usually have known payoffs or quantifiable consequences when you make decisions in the game. So with game theory, there's a few terms. A game is any set of circumstances that has a result dependent on the action of two or more decision makers, which are players. Players are decision makers within the context of a game that are trying to use a strategy. The strategy would be a complete plan of action that a player will take given the set of circumstances that might arise within the game. Then within each game they have a payoff, and that is the payout that a player receives from arriving at a particular outcome. And then we have an information set, which is the information available at any given point in the game. And then there finally is the equilibrium, which is the point in the game where both players have made their decision and an outcome is reached. So the hawk-dove game that we're going to be simulating basically has an outcome of a prize and a cost. So each player only has two options. They can either choose to be a hawk or a dove. If both players choose a hawk, you can see here in this matrix here, this is the payoff matrix, that they would have to subtract the cost from the prize and then split that value. If player 1 chooses to be a hawk and player 2 chooses to be a dove, that hawk wins that prize. If I choose to be a dove and the other person chooses a hawk, then I would lose everything. But if both players choose dove, then we just split the prize. So as you can see, it's kind of more beneficial for everyone if we just chose to be a dove all the time because we're losing the least amount. So with game theory, there's a few assumptions that are come into play. We have the assumption of rationality and maximization, which is basically all players within the game are striving to win and striving to maximize their payoffs. So they're always playing to win the game. No one can be a beneficiary and let the other person win. That's not the case here. And then the other assumption is that there's common knowledge. So all players know the rules of the game and each player's other utility functions. So we know everything about the game and about the other player. So in our project, we're going to be looking at this exception here, and we're going to have incomplete information. And so we're going to do it from the perspective of player A, and player A will play player B with an unknown strategy.
So let's look at some of the literature we were able to look over to kind of give us a little background on this project. So one of the literature reviews I did was on Terrorism and Game Theory by Sandler and Arce in 2003. Basically what they did is they looked at game theory and game theory with its application to policy. So for example, the U.S. and Israel have a policy that they do not negotiate with terrorist organizations. So this is an approach to game theory that says that, again, like the hawk-dove, the hawk is being aggressive, the dove is being non-aggressive. So in this sense, it is a stance, and what we could do is the Terrorism and Game Theory paper basically said that now we can look at terrorism through the eyes of game theory to make a better decision on what we want to do in any given instance, specifically for the U.S. when it comes to terrorism. The second literature review was on Monte Carlo techniques in games itself. So Raj Kumar, the author of this paper, wrote basically the advantages and disadvantages of using Monte Carlo techniques in games such as Bridge, Scrabble, Go, which is a big one because this one was recently won in 2008 with a 9-stone, I think, advantage, Clobber, and Backgammon. So what is our research question? Basically what we want to do is let's use Monte Carlo in a hawk-dove game theory and see how quickly player A can discover the strategy of player B and take advantage of that strategy. In the end, taking advantage of the strategy is what we will rate as player A discovering the strategy of player B. So what is our hypothesis? We assume, and our null hypothesis is that player A is able to learn, quote, player B's strategy. And our alternative hypothesis is that they will be unable to learn player B's strategy. And we expect that the null hypothesis will be true. So how will we do this? A general overview of what we're going to do is obviously code in a hawk-dove game in MATLAB, pitting player A against player B. They both start with the same amount of quote-unquote money, or in other words, like a cost function. So they start with the same even keel. And then they look at player B is randomly assigned a knowledge value that remains static throughout the simulation. In other words, this is their strategy. So they're randomly assigned a strategy of either hawk or dove. And player A will then make a decision based off assumptions made about player A through their outcomes. So basically, what you'll look at is after the first round is played, an outcome will be determined, and then player A will look back and try to reinforce good outcomes for player A and obviously suppress bad outcomes. So then player A will basically make a next decision, building their strategy until player A bankrupts player B, which means that player A really kind of sends player B to zero when it comes to the amount of money that they have at the beginning. So what is the business case? When analyzing competitive environment between two players, so we can look at politicians, businesses, adversaries, we can simulate advantages of one player keeping a static approach to a competitive environment versus a player that will look to optimize their approach by analyzing their past events. So for example, we can look at business strategies, a competitor that basically will look at resulting, for example, sales numbers for each period, and then be able to go back in and adjust their strategy based on every single result and see if they can actually optimize their results. So with that, here's some of our sources. And the gist of it, again, is that we're going to be using the Monte-Carlo to simulate a hawk-dove game using game theory techniques. Again, hawk-dove is something that is similar to like the prisoner's dilemma or other game theory examples like that, which are fairly academic, and then try to see if we can adjust one, so using Monte-Carlo to where player A will be able to learn about player B's strategy. So thank you for watching.